We have plenty of reactions in chemistry. The question is, which reactions count as oxidation reactions, oxidation reduction reactions, redox reactions? Before you even begin solving this question, you have to have good knowledge of determining oxidation numbers. What we did before, as I told you in the last video, is crucial. You could not do this without knowing how to calculate the oxidation number. So let's begin. I will look at the oxidation numbers on the reactant sides of the atoms and of course on the product side and determine if there is a change. If there is a change, then yes, you do have a redox reaction. So we have CH4 here. Briefly, I'm going to go over this very briefly because we just did plenty of examples. CH4 would mean that we have 4 hydrogen atoms. They're attached to nonmetals. Carbon is a nonmetal. That's a 0 formal charge. So we have a +4. Each is a +1. So go back to the rules and see that hydrogen was attached to a nonmetal. It is a +1. So we have 4 of them. I already took 4 times +1. So C is unknown. X, if you solve for X, it would be a -4. So in this case, C is a -4, H is a +1. For O, this is an element by itself. It is a 0. So again, this is an element. So watch, we have -4 + 1, 0. Let's check to see if the oxidation numbers have changed. We did CO2. It was one of the examples that we did. Let's look at it rather than solving it to save some time. Well, CO2 came out to be, C was a +4 and O was a -2. So C is now a +4 and O is a -2. We still have to check this. In H2O, again, H is attached to a nonmetal, so that's +2. Overall is a negative. Oxygen would be a -2, so that's a 0. Very well. So what happened here is, let's check if 2 elements have changed their oxidation numbers. Let's start with C. C looks like it went from -4 to a +4. That's a change. H did not change. +1, still a +1. O went from a 0 to a -2. So that's a change. Therefore, if there is a change in the oxidation numbers, then this would be a redox reaction. However, let's check the next example. Again, I'm going to do this really quick just to show you. So Na would be a +1, it's a group 1. Cl would be a -1. Ag would be a +1. All of these are from your ion sheet. N would be a +5. And O would be a -2. Ag would be a +1. Cl is a -1. Na is a +1. N is a +5. And again, O is a -2. So I'm going to list them for ease of seeing them. Na was a +1, went to a +1. Nothing changed. Cl was a -1 or a -1. It still is a -1. Ag is a +1, went to a +1. N was a +5, still is a +5. And of course, O was a -2, still is a -2. There's no change in oxidation numbers. So therefore, you do not have an oxidation reduction reaction. So that's what happens. Now, since we're here, we need to get in the habit of writing oxidation reduction reactions in what we call half reactions. And a half reaction is one of the two parts of an oxidation reduction reaction, one part which involves the loss of electrons, of course, that would be oxidation. And the other is the gain of electrons, which is reduction. And they tell you here a very simple and important piece of information. An increase in the oxidation number and a decrease in the oxidation number. So write this and make sure you keep this in mind. If you have reduction, the oxidation number goes down. If you have oxidation, the oxidation number goes up. So you have to keep that in mind. Let's look at the last example. How would I separate CH4 plus O2, etc.? What I would do it is the following way, is I would take this, and again, for just simple reasons here, I'm recopying it. I would take the one that has the C in it, so that would be CH4, CO2. Again, you want the part that has the carbons in it, so that would be the CH4 and the CO2. What happened here? Well, we noticed that it was -4. It went to a +4. So what happened to the oxidation number here? Did it increase or decrease? So it went from -4 to a +4. That's an increase in oxidation number. Therefore, you have oxidation. Of course, the O2 would apply, of course, to the CO2 and the H2O, but for this simple reason, we'll just choose the other one, the H2O. Again, it was a 0. It went to a -2. So if it's 0 to a -2, what happened to the oxidation number? Did it go up or down? What's smaller, 0 or -2? -2. So therefore, you have reduction. So again, that's how we would determine what you have. And finally, I'm going to mention this here, but when we meet, I will give you an analogy. An oxidizing agent is a substance that causes this substance to be oxidized and thus loses electrons. And keep in mind that the oxidizing agent becomes reduced. I will just make it simple for you. Once you find the reduction, just couple that, pair that with oxidizing agent. So the oxidizing agent causes something else to lose electrons, but those electrons are absorbed, are taken by the oxidizing agent. Therefore, it undergoes a reduction. The reducing agent is the opposite. So this one causes the substance to be reduced and gains electrons. So again, reducing agents become oxidized. So again, an easy way around it is oxidation is coupled with the reducing agent. I will give you an analogy when we meet next time to clarify. You can think about it, but that's a very, very quick way of understanding it and remembering it.